Hello everyone, welcome back to EduNam YouTube channel. Let's go for the third main. In the third main, we are going to find the LCM and HCF only as we did it in the second main. But the twist is here there are three numbers. So same procedure we are going to follow when there are three numbers also. So come, let's learn how to do this. First, let's do the prime factorization for each number. 2 6 is 12, 2 3 is 6, 3 1s are. Same way, this doesn't go in 2, so directly we'll take 3. 3 5s are 15, 5 1s are. Same way, 3 7s are 21, 7 1s are. So the prime factorization is 2 into 2 into 3. Here it is 3 into 5, and in this case it is 3 into 7. So when you see here, you can make out 3 is common in all the three numbers. So HCF will be 3. Now to do LCM, what we will do? First we will write the common one, that is 3. 2 and 2 are not common. Next, then 5 and 7. So when you multiply all this, you will get the LCM. 3 2s are 6, 6 2s are 12, 12 5s are 60, 60 into 7. 7 6 are 42 and 0. So 420 will be the LCM and 3 will be the HCF. Same way, there are other two problems, that is 17, 23 and 29 and 8, 9 and 25. So those two problems are for homework. Please solve them and post your answers in the comment. If you have any doubts, please feel free to ask so that I'll explain those two problems in the same way and show you. Come, let's go for the fourth one. Fourth problem, they have told, given that HCF of 306, the numbers are 306 and 657. The HCF of these two is given to be 9. They have already given HCF. They are telling you to find the LCM without doing the prime factorization. Whatever method we use now, we should not do that. Without doing that, you should find the LCM. So how do we do? LCM into HCF is product of two numbers. Using this formula, we can do it. So the two numbers are 306 and 657. HCF is 9, LCM we don't know. So we'll keep this L on the one side and move other things on the right hand side. So when you move this, L is multiplied with 9. If it comes this side, division. So 9 will come down. Now, let's see whether we can cancel any of these terms. 3 3s are 9. 3 1s are 3, 0 as it is, 3 2s are 6. Then again 3 1s are 3, 3 3s are 9, 1 carry over, 3 4s are 12. We are left with 657 into 34. So 4 7s are 7 are 7, 7 2s are 14, 7 3s are 21, 7 4s are 28. 4 5s are 20 plus 2 22. 4 6 are 24 plus 2 26. Same way we'll go for the next step. 3 7s are 21. 3 5s are 15, 16, 17. So 1 carry over 7. 3 6 are 18 plus 1 19. When you add these two, you will get 22338. So this will be the LCM. So using the formula, we have found out the LCM. Same way they can ask you questions like giving LCM and two numbers, find the HCF. Same way they can give you HCF, LCM and find one number. These kind of questions can be asked in the exam. These are called as application based questions. Sometimes these kind of questions are asked in MCQs also. So practice well. Let's go to the fifth problem. The fifth problem is check whether 6 to the power of n can end with the digit 0 for any natural number n. So 6 to the power of n. So when we substitute n by natural numbers, for example 6 to the power of 1, it will become 6. Same way 6 to the power of 2 is 36. Like that, the question is, when any number is given in the place of n, the answer should have 0 or 5. In this case, they are asking only for 0, so you can check only for 0 in the units place. For example, will we get any answer like 20, 400, or 860, something like this? Whether we get 0 in the ones place is the question. So how do you find out that? First, let's see which all numbers will have 0 or 5, 0 in the ones place. Whenever we are multiplying any number by 5 and any number by 0, the last number will be 0. So this is the logic we follow. Now let's take the number which they have given 6. So if you do prime factorization for this, 2 3s are 6. So 6 can be written as 2 into 3. So 6 to the power of n can also be written as 2 to the power of n and 3 to the power of n. So in this case, we will not get 0 for 2 for all the numbers like 2, 4, 6, 8, 0 can be the units place for 2. For 3 it can be many numbers. But particularly we are not getting a 0. 0 is a possibility. Here also 0, 3 tens are 30. So it will have 0, but it's a possibility, not a confirmed thing. So from this we conclude by saying that 6 has two multiples and we cannot get 0 in the ones place. Now let's go to the sixth problem. Sixth problem, explain why 7 into 11 into 13 plus 13. Be very careful, it is plus 13 and into 13 here are composite numbers. We have to prove this is composite. So first of all, what are composite numbers? Composite numbers are the numbers which have more than one factor, that is 1 and itself and more than that. So if we consider this, this is one term and this is one term. So 13 is common in both. I'll take 13 common out. It will become 7 into 11 into 1 because I've taken 13 common out. Plus since I've taken this out, it is 1. So 7 11s are 77 into 1 plus 1. So it will become 77 plus 1. So 78. 13 into 78. Now 78 if you do prime factorization, it will be 2 3s are 6, 2 9s are 3 1s are 3s are. Now by this you understood that 13 into 2 into 3 into 13. There are 4 prime factorization numbers for this particular number. 2, 3, 13, and always 1 is a factor. So 4. Now we got 4 factors for this number. When you have more than 1 or 2 factors, it's a composite number. So obviously this number will be a composite number. The second part of this question has the same similar problem, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. So 5 and 5 are common. Take that out, multiply this and do prime factorization. If you are getting more than 2 factors, it's a composite number. So let's go to the seventh problem. Coming to the last problem of this exercise 1.1. It's a very interesting problem. It's application based problem. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So I'll first explain you the problem so that you will understand and then we will start solving it. There is a circular path. You can imagine a walking track of a park or something. So this is the entry line, entry gate or something. So one person starts from here and he'll take 18 minutes to go one round the park. Same way, second person also starts at the same time and he'll take 12 minutes to go around the same path. So, second person by 12 minutes, he will finish the path, but the first person will be somewhere here at that time. I hope you understood the problem. So at some point, both of them will meet when they are going around the track. So what is that point where they meet? So generally, if we think of this, first round, he will take 12 minutes. Second round, it will become 24 minutes. Third round, it will become 36 minutes and so on. Same way, the person who take 18 minutes, first round 18 minutes, by the time he completes the second round, it will be 36 minutes. So at 36 minutes, both of them are meeting. Isn't this a very nice trick that you can follow? Yes, at 36 minutes, both of them are meeting. The difference is the second one has gone only 2 rounds, the first one has gone 3 rounds. So this logic is very simple, but when bigger numbers are given, you can't use this method. So what method to use? What have I written here? These are the multiples of 12 and 18. So in that I am taking a common multiple, and this is the least common multiple. First I got 36, that one only I have considered. So what I have to find out? LCM, least common multiple of these two, will be 36. So you can use any traditional method to find this. I will just show you how to do it. 2 nines are 18, 2 6 are 12, 3 threes are 9, 3 twos are 6, then again 3 ones are and 2, and 2 will be left. So 2 threes are 6, 6 threes are 18, 18 twos are is 36. By traditional method we got 36 to be the LCM of 12 and 18. Same way in this method also we got 36. So after 36 minutes both of them are going to meet. We have completed the first exercise of real numbers. Keep watching our channel for the second exercise, that is part 2 of real numbers. I hope this video will be very useful to you all. We have put in a lot of efforts to bring in front of you the complete chapter explanation, and I've explained it as easy as possible so that all the students should understand. Please forward these videos to many students so that it will be very useful for them, and also put your comments so that it will be an encouragement for me to do much more videos like this. Also do your homework and post all the answers in the comment. Thank you so much, and keep watching Edunam channel, and please subscribe to our channel and support us to do more. Thank you.